Again, my name is Andrijana Đurđević, and I will present paper with title Numerical and Experimental Determination of Stress and Strains in Connecting Lugs. This picture shows a breakdown of rotary excavator from surface mine. The accident occurred due to the failure of connecting the elements. Here, you can see the lug that led to the breakdown of excavator. The excavator breakdown prompts us to examine connecting lugs numerically and to confirm numerically obtained results with experimentally. Here are geometrical shapes of structural elements for connecting. All elements are made of steel S355 material and were tested experimentally. First, we done numerical analysis. You can see the lug echelon, that is connection element, and boundary condition of support loading, and 4 different finite element meshes, and core intensity was 10,000 newtons. This was done in order to adopt the finite element mesh for further numerical calculation. The model were created in COMI software, developed at Faculty of Mechanical Engineering, University in Belgrade. The formed lug models maximum displacement and stress field, that is equivalent stress, for 4 different finite element models meshes. Is here. We can see that the maximum equivalent stress values is 187 megapascals, and we choose model 1 as its mesh model. After the surface model, the examination of volume models were started using finite element methods. Volume calculation model of lug is here, and the 4 models shaped with maximum displacement. Maximum displacement is in millimeters. Here is display of stress field. Maximum equivalent stress was 160 megapascals. Here is model of Italian lug with the same finite element mesh, boundary conditions, and loading, but in Abacus software. Force intensity was 10,000 Newton, and the mesh model like model 1. You can see here the stress field Mach of lug U, D times R times D times T was 12 times 18 times 18 times 10 millimeter, and force intensity 2000 Newton. Here is the geometry and dimensions of lug, which was tested experimentally, and lug U with computational model with boundary condition. Boundary conditions. The deformed shape of U model with maximum displacement is shown here, and display of stress field around the lug hole. Equivalent stress is here again, that is in Abacus software. Display of deformed model with maximum displacement and the equivalent stress values are here. This shows how the strain and equivalent stress can be reduced if material is removed by drilling holes. You can see here just 1/2 of model of lug, connecting lug, and you can see, because that is 1/2, 1, 2, 3 holes. In the second connecting lug, here are 5 holes, and here are 7 holes. And you can see the values of stress. After numerical analysis, we had experimental work, measurement acquisition system of stress and strain measurement laboratory of Department of Strength of Construction in Faculty of Mechanical Engineering, University of Belgrade, was used for experimental testing. On the experimental elements, the measuring positions was painted with white spray. You can see. And then black dots were applied over white surface, also with spray. The camera tracks the relative movement between two black dots. And here is that stochastic pattern and measuring position. It was made 3D optical strain and stress analysis based on digital image correlation RMI system, arrangement of measuring equipment and measuring system are shown on these figures. Here is experimental element positioned for measurement. That is like stochastic pattern. And the formation was calculated using a virtual tape measure. The stress is calculated according to given expression for stress, display of field of deformation and calculated stress for lug U at the measuring position MM1. You can see that is this area, this, and that is value of stress. In this table is given comparison of analytical, numerical, and experimental results. You can see the values of stress, and the difference is about 4%. Examples of application in practice are here. You can see construction for electrical equipment, and here are container terminals for mining industry. And conclusions. The paper presents results of stress and strain tests of structural element with geometric discontinuities. The finite element method as a numerical method and digital image correlation method as an experiment were used for tests. The static calculation was performed using finite element methods. Conclusions obtained by examining this type of structures can be included in process of designing new similar structures, and knowledge gained during the realization of this work can be directly applied to identify the behavior or real structures in their working condition. Thank you for your attention.
Thank you. So we can proceed with the questions.